Hello everyone. In this section, we're going to study Taylor series and the Maclaurin series. So Taylor series means we want to express a function as a power function. Do you still remember in the last section? We can have a quick review. 11.8, we learned the power series. What's a power series look like? We studied that is Cnx to the no, like x minus a to the n power. That means centered at a, right? So if we write this out, it's like c0 plus c1 x minus a plus general term cnx minus a to the n. Okay, so this is called the power series. So in this section, the goal, we want to find a power series for a given function. Okay, because we know this in the last section we discussed convergence or divergence of the power series. If convergence, it has to converge to sum, right? And the sum is a function. Actually, if it's converge to a function. And today we do just backward. Given function, how to write out the power series. Now let's take a look at this thing. Assume our function equals, okay, we write down the power series. a1x minus a square and plus anx minus a to the n. This is the power series, and we want to, if we can find all the coefficients, then we can just write down our power series, right? We want to find all the ans. Okay, so let's see how to find those ans. If we take the first derivative of this function, let's take a look. a0 go away because it's constant derivative is 0, and then becomes a1 plus, let's see, the third term 2a2x minus a, and the next term should be 3x minus a squared, and this term is nanx minus a to the n. Is that right? So how to find the a1? Let's take a look. If we make x equals a, so let's see, what is f prime a? F prime a, if we make x equals a, all the term here, x minus a, they will be 0. Is that right? So f prime a just equals a1. Then we can find the a1, right? And how to find the a0? Same thing from this function. What is if we make x equals a, fa equals a0? So a0 is fa, a1 is f prime a. Let's take a look at second derivative of the function. So the second derivative is the derivative of the first derivative. Let's see, 2a2. Okay, we don't do 6. We can write down just like 3 times 2. a is 3, x minus a. n minus 1, an x minus a to the n minus 2. Okay, let's take a look. How to find the a2? So if we make a f prime x equals a, f double prime will be 2a2. Is that right? Because all the other terms will be 0. And what is a2? So we know a2 is f prime double prime over 2. Okay, let's do another one, and then we will do the general formula. Let's see what is f triple prime. Third derivative, 3 times 2 times a3 and plus, okay, n minus 1, n minus 2, a n x minus n to the n minus 3. So same thing, we make x equals a, this equals 3 times 2, a3. So we want to write this as 3 times 1. How about 3 factorial times a3, right? So a3 equals f triple prime over 3 factorial. So actually, this is how we get to the coefficient. If you look at a1, a2, a3, so we can do the general formula. an equals what? F x nth derivative at a and divided by n factorial. So that's the formula for our coefficients, an. Okay, so if we want to write down our function, so a naught, if you look at beginning how we get a naught, that is fa. And how to get a1, just the first derivative at a and x minus a. How about x2? a2, second derivative at a 2 factorial. And a3 is third derivative at a 3 factorial. And the nth term is fn's derivative n factorial, that's an an, and x minus a to the power n. Right? So this actually, you can see, given a function, we can write down the function as a series, and this is also power series, and we call this series Taylor series. So now let me give you the definition. Definition 1, Taylor series. Okay, let's take a look. If f is a function with derivative of all orders, that means the function has all derivatives with different orders. Then the Taylor series is generated by the function at x equals a. A is like the center, right? Yes. Okay. It's given by this form. So it's going to be the sum notation is this way. an x minus a to the power n. What is fn? N's derivative evaluate at a and divide by n factorial, and n start from 0 to infinity. If we write this out, so it's like f naught plus a naught plus a1 x minus a. So all the coefficients are, we calculate coefficient before, so it's like f prime a x minus a double prime over 2 factorial x minus a squared, nth term fn's derivative n factorial x minus a to the power n. This is called Taylor series, right? And if we make a equals 0, if a equals 0, it's called Maclaurin series. So the Maclaurin series is this way, generated by f. Okay, it's just f not 0, f prime 0, and here is x, double prime. So just make all the a equals 0. So x squared f to the n 0. And some notation is f to the nth derivative as 0 n factorial x to the power n start from 0 to infinity. Okay, so we have two power series, one centered at a, one centered at 0. Now let's take a look at the example. How to find the Taylor series from a given function. Find Taylor series generated by this function 1 over x at 2. Now let's take a look at the function. So firstly, let's write down our function in this way, because in the power function way, because we want to find the derivative. Okay, and what is the first derivative? We just calculated first several derivatives. So f prime should be negative x to the negative 2, right? And the second derivative, 2x to the negative third. Third derivative, negative 6x to the negative 4. Okay, and we can just stop here. So let's see how we evaluate f a. So a is 2. So here f a equals what? So all the coefficients are evaluated by f a, f prime a, those c, right? So f a is 2 to the negative 1, so which is 1/2. And let's see, f prime 2 equals what? F prime 2 is plug in 2 to the negative 2, so which is negative 1 first. F double prime 2, 2 times 2 to the negative 3, so should be 2 over 8 is 1 first. And third derivative at a is negative 6 times x 2 to the negative 4. So negative 6 over 16, so should be negative 3 over 4. Okay, let's see, then our Taylor series should be f2. So here let's write down the formula. f2 plus f prime 2 x minus 2. The second term, don't forget to divide by 2 factorial. And the third derivative at 2, 3 factorial. Okay, like this. And then f2, which is plug in, f2 is 1/2. f prime 2, negative 1/4. And 1/4 divided by 2 factorial. So which is 8 actually. Okay. And here that is negative 3/4 divided by 3 factorial, right? X minus 2 cubed. And if we simplify the coefficient, 1 over 8 x minus 2 squared, and here's 3 cancel with the 3, and should be 1 over 8 x minus 2 cubed. Okay, so this is the Taylor series generated by 1 over x. Is that right? Let's take a look at the exercise problem. Find the Taylor series at 0. So actually this is also Maclaurin series, right? Okay, you can try. Now let's, I'm going to give you the solution to this one. I will do this way. I just write down fx. f prime x. Okay, I can stop here. And then f0, sine 0 is 0. Cosine 0 should be 1. Sin 0, 0. Cosine 0 is also 1, so negative 1 here. When we write down Taylor series, should be 0 equals 0 plus 1 times x, right? And plus 0 times x squared minus, actually 2 factorial, but it's still 0. 1 over 3 factorial x cubed. If we rewrite this, it's going to be x minus 1 over 3 factorial, this one. And if we write more terms, so it should be like this. And minus is alternating. Okay, if I want to write down this as sum notation, you don't have to, but just in case sometimes in a solution, they may write in this way. So it's going to be, definitely there will be sign, right? And here we should be 2n. Depends on your n start from 1 or 0. So if I say 2n minus 1, here, same thing, x to the n minus 1 power, 2n minus 1. They are the same thing. So let's see, the first term is 1. So 2 minus 1, so n should start from 1. And here, this is 2n, because the first term is positive. So this is the sum notation, but if you can just find here, that's okay. Let's see. This is the first exercise problem. The second one. Find Maclaurin series for this function and its radius of convergence. Okay, so here I say Maclaurin, that means A is 0, right? Same thing. I'm going to give you the solution. But you should do this problem by yourself. All the derivatives are all e to the x. Right, okay, x. So when we evaluate them, fa, so which is f0, this case, 1. They are all 1. So if you write down the Taylor series, Taylor series going to be f0, so 1 plus 1 times x plus 1 over 2 factorial x squared, 1 over 3 factorial x cubed. If we write the sum notation, going to be x to the power n over n factorial, and n start from, because the first term is 1, start from 0 to infinity, like this, right? So this is the Maclaurin series of e to the x. And second question, radius of convergence. We can use the ratio test. Okay, whenever we have factorial, we like to use the ratio, right? Ratio test. Okay, so it's going to be this over n plus 1 factorial times. And the simplify, going to be x times n this case what? 1 over n plus 1. So what's the limit of this one? You can see on the top is 1. Denominator goes to infinity, so this term goes to 0. So no matter what, for what x, this goes to 0. In this case, converges, right? So what's the radius of convergence? Let's see. So for all x, the series converges, right? In this case, if we want to draw a number line, something like this. So for all x convergence, so where is the our r? R should be infinity. Is that right? So that's the radius of convergence. Next definition is called the Taylor polynomial. Okay, Taylor polynomial of order n. Let's see this definition too. Taylor polynomial of order n. So series is a sum of infinite terms, right? Polynomial of order n means it's going to be a polynomial, finite terms by f at a is the polynomial like this. So here we use p as polynomial, and of order n, we write down n there, and this means Taylor polynomial of order n. So it's going to be the first n terms are the same as Taylor series fa, f prime a x minus a, f second derivative 2 factorial x minus a squared. And here we just write down till the nth term. A n factorial x minus a to the n. Okay, this is called the nth term polynomial. Polynomial of order n. Now let's take a look at the example. Find the Taylor series and the Taylor polynomial of order 4 generated by the function cosine x at 0. So this is similar to the previous example. Find the Taylor series of sine. Let's do this again. So first write down fx, right? And then find all the derivatives. So we usually just do the first several terms. So f prime should be negative sine, negative cosine, and derivative negative sine, cosine should be sine. And then evaluate them all at 0. Negative should be 0 here. Negative 1 should be 0. So let's write down our Taylor series should be f0 plus f prime 0 x f second derivative divided by 2 factorial x squared 3 factorial x cubed. That's the formula for the Taylor series. Now change f0 into 1 and plus 0 times x minus 1 over 2 factorial x squared 0 times x cubed, like this, right? Actually, if you do one more terms, you will see that's going to be this x to the fourth. And the Taylor series to general is going to be negative 1 to the, you can see, only the even terms left, right? So x to the 2n. So here 2n factorial. And here the first term start from positive, also 2n. And n start from, you can see, should start from 0 to infinity. This is the Taylor series for cosine. And the polynomial of order 4 should be what? Just choose the till, here. So just like to the fourth order derivative. Just like this. Okay. Here's the exercise problem. Find Taylor series of orders 3 generated by this function. I'm going to give you the solution later. So we can stop here this section. All we need to know is just Taylor series. Okay, and Maclaurin actually is a special case of Taylor series because it's centered at 0.